Hello, Calculus. This is going to be part 2 of the 5.4 video over the exponential function e. Before we start the main lesson, I want to do a bell ringer real quick to refresh us on the part 1 video. So let's say you have e to the 7x and we're supposed to derive it or find the derivative. Now remember from part 1, the first thing you need to do is take a look at the power and then find the derivative of that. So the power is 7x, the derivative of that is going to be 7. And then you're just going to multiply that by the original. And what I mean by the original is I'm talking about the entire original function. So in other words, take e to the 7x. That is the original. So there you go. You have your two parts. Take the power times the original, and you will get your first derivative, which will be 7e to the 7x. There you go. So that was just a quick refresher of the main topic we talked about in the first video. But now I need to ask you, what if instead of giving you the original function, what if I gave you the derivative and I wanted you to find what the original function was? Or in other words, how do we find the integral or antiderivative? That's what part 2 is going to be about. Basically finding the antiderivative of our e functions. So that's going to be the topic for part 2, the integrals of exponential functions, or in other words, now finding the antiderivative. So let's go ahead and hop to it. And actually finding the antiderivative is actually going to be very familiar because we're going to use something you have used before. And that is u substitution. Or in other words, you're going to take a part of this function and you're going to label it as u. And you probably can guess what you're going to label as u. It's going to be the power. The power of the e you will always want to label as your u. And of course, once you've done the u, we'll then take the derivative of both sides. You derive the right, derivative of 9x will be 9, and let's label that as derivative of x, or dx. On the left side, the derivative of u is 1, and of course, let's label that as the derivative of u, du. But of course, 1 times du is just du, so you can leave it like that. So now we have the pieces we need. Let's double check. We have that u is going to be 9x, and 9dx perfectly matches up with du. So we got what we need to do u substitution. So let's do it. So we got the integral of e, but instead of 9x, we're going to put u in its place by definition, so e to the u. And then here, instead of 9dx, since it's equal to du, we're going to put du in its place. All right, now that we've done u substitution, now it's much easier to find the integral. So remember, the integral, gotta think about this. I had a way to explain this. Give me a second. I had a way to explain this. I got it. Here's how to explain it. So, to explain how to find the antiderivative, let's say I gave you e to the x, and I asked you to find the derivative. And you know how to find the derivative, right? You would take the derivative of the power, which is 1, and then you multiply it by the original, and the original is ex. In other words, 1 times ex would just give you ex. I gotta get past this, come on. Okay, we're done. So if you have the original function, this is how you would find the derivative. You do 1 times EX, which is EX. But wait a minute, do you guys see something peculiar? You have the original, but when you found the derivative, it turned out to be the same thing. If you have e to the x, just e to the x, its derivative is also e to the x. That is not a typo error. That is actually a common fact, that e to the x, specifically just e to the x, is its own derivative. And of course, wouldn't that also mean that its antiderivative would also be the same thing? So literally, derivative of e to the x is e to the x. The same way would work in the opposite direction. It's its own derivative, and it's its own antiderivative. So in other words, the antiderivative of e to the u is just e to the u. And then, of course, your plus c. I kid you not, that's actually how it works. And then all that you have to do is you got to plug the u back into its original form. And the original u was 9x. So you'll have e to the 9x and then plus c. Again, make sure you write that down. If your regular function is e to the x, its derivative will also be e to the x, as you just saw by using our derivative rule, which also means the second derivative would follow the same rule. It's the same way for derivatives, and it's the same way for anti. That will be a very useful tool in this lesson. I apologize to not explain that sooner, but now you know. So there you go. There's your antiderivative, e to the 9x plus c. So let's try that again, just so that we get the hang of it. So here we got the integral, and we got to do the antiderivative. And usually for this, the best way to do antiderivative is with u substitution. So let's go ahead and take the power, which is negative x to the 6, and then we'll derive both sides. On the right side, when we derive, multiply the 6 to the front, you'll get negative 6x. Subtract 1 from the power, and you get to the 5th. And we'll label that as dx, or the derivative of x. And then, of course, on the other side, you'll get 1 times du, which is du. Okay, we got all the pieces we need. And make sure negative 6x, negative 65x dx matches with what we need it to match up with. So we're good to go. All right, so let's do the substituting part. So instead of negative x to the 6, I'm going to put in u in its place. And instead of negative 6x to the 5th, I'm going to put du. There you go. And just like before, e to the x, or also e to the u, it's its own derivative, and it's also its own antiderivative. So the antiderivative of e to the u is just itself, e to the u, and then plus c. And then all you have to do is put the u back into its original form. And the original form of u was negative x to the 6. So negative x to the 6, put that back as its power, and then plus c. So there's your antiderivative. And just so you know, if you're ever in doubt, if you're doing the antiderivative correctly, you can always check. Or in other words, take your answer, find its derivative. So in other words, derive the power, where the power is negative 6x to the 5th, and then multiply by the original. And the original is going to be e to the negative x to the 6, which, of course, just gets you this. Negative 6x to the 5th times e to the power of negative x to the 6. Now, does this match what we started with at the very beginning? Sure does. I mean, the negative 6x to the 5th is in the back instead of the front, but that's fine, because multiplication It doesn't matter which way you multiply. You could do 2 times 3 or 3 times 2. You're still going to get 6. The same way it works here. So that's something really important to know, especially for any future quiz/test, is that you can always check your antiderivative by deriving it. Just FYI. All right, so now let's move on to some other examples. Let's say I have this example and I need to do the antiderivative using u substitution. So again, I'm going to take the power that is equal to u, 3x plus 1. Now I'm going to derive the left and the right. If I derive the right side, derivative of 3x is 3, derivative of 1 is just 0, but I don't need that. So derivative of the whole thing is just 3, and I'll label that as dx. Derivative of u is 1, and then I'll label that as du. Now, I'm going to leave it as 1 du for now. You'll see why in a moment. But now take a look. Here, I just have regular dx. I don't have 3 dx. I need to get rid of that 3 somehow. And of course, you guys are familiar with how to take care of that 3. We just have to divide it to both sides. And dividing it by 3 will make it 1/3 du on the left, and then I'll just have dx on the right. So that will help this dx match up with this dx. And that will better help us for the u substitution. All right, so let's substitute away. Right over here, I'm going to have e, but instead of 3x to the 1, I'm going to put u in its place. And for the dx, I have that dx is equal to 1/3 du. So that's what I'll put in the dx place. I'm going to put 1/3 du. Okay, we've done all the substituting we can. And some of you may feel a little uncomfortable taking the antiderivative of du with that 1/3, but if you guys remember, if you wish, you can put that 1/3 in the front and deal with it later. So in other words, this will become 1/3 in the front, and then you just got to find the integral of e to the u, and then du. So let's go from there. So the derivative of e to the u is just e to the u, and then plus c. And then the 1/3 in the front just becomes 1/3. Because remember, the antiderivative of e to the u is itself. It's basically its own derivative and its own antiderivative. Makes it really easy for you guys. And then the 1/3 will just stay in the front. And then all you have left to do is plug in the u back in its place. And the u, what was the u again? The u was 3x plus 1. So the power, 3x plus 1. There you go. And of course, if you wish, you're more than welcome to rewrite your answer as e 3x plus 1 all divided by 3. They're technically the same answer. I will accept either or. They're the same thing. And on the next slide, it's basically just showing you exactly what I showed you, how to find the antiderivative of this using u substitution. And you do end up getting the exact same answer, just like I showed you, if you ever wanted to see what how the textbook does it. All right, so let's do one more example, then I'll have you try one on your own, and then this video is done. So let's do it. Okay, so once again, I need to find the antiderivative of e. To help me out, I'm going to have to do u substitution. So u is going to be equal to negative 2x. Derive both sides. On the right, my derivative will be negative 2. I'll label that as dx. On the left, derivative of u is 1, and I'll label that du. And in this case, I only have dx. I'm not supposed to have negative 2 dx, so I'm going to have to get rid of that negative 2. So to get rid of the negative 2, I'm going to have to divide it to both sides. And that will give me negative 1/2 du, and that will be equal to dx. Okay, now I have all the tools I need to plug in the substitution. So here's my integral, e, but instead of e to the power of negative 2x, I'm going to replace it with u. So u here, and in place of the dx, my dx is the same thing as negative 1/2 du, so I'll replace that with negative 1/2 du. And of course, if you don't want to deal with the negative 1/2 right now, you can go ahead and take it and move it to the front. So we'll have the integral of negative 1/2. And then inside the integral, you'll have e to the u du. And then from there, derive away. Or not derive away, do the antiderivative. That's what I meant to say. Take the antiderivative of e to the u. It's basically the same thing as e to the x. It's its own derivative, and it's its own anti. So the anti will just be e to the x. Or I meant not e to the x, e to the u plus c. And then take the negative 1/2. That goes in the front. And you're 99% done. You just have to take care of the power. Because we can't leave u in our final answer. We got to go back to its original. And the original u was negative 2x. So put in the original power, negative 2x plus c. And there you go. And as always, you can always double check your answer by finding the derivative of your answer. And if the derivative of your answer matches what you have up here, you're good to go. I mean, actually, out of curiosity, let's just go ahead and check for skittles and giggles. Now, the negative 1/2, since that's not actually part of the e, you're actually more than welcome to just keep that in the front while you derive the power and then multiply by the original. So, look at your answer, take the power, which is negative 2x, and derive it, and derivative is negative 2. The original, in this case, is e to the negative 2x, e to the negative 2x, and then multiply away. First, you'll take the negative 1/2 times negative 2. Simplify that. That should, that just gives you positive 1 when you multiply these. And then multiply that by e to the negative 2x, which just gives you e to the negative 2x dx. Or in other words, this is the derivative of x. Now let's check the very beginning. Does that match what dx is supposed to be? Dx is supposed to be e to the negative 2x. Done. So therefore, we have checked, and thus you know for sure that this is the correct antiderivative. The only thing you'll have to remember is just put the negative 1/2 in the front, like you've done with all the others, and then just derive e to the negative 2x and go from there. That's how you will check those answers. All right. I feel like you guys should be pretty confident by now. I want you to go ahead and do the last one on your own. Go ahead and pause the video and try it. And once you're done, I'll write the answer for you to check. All right, you should have resumed the video by now. This one actually is very similar to the previous one, just a single number change. But for your antiderivative, you should get this. You should get 1/4 times e to the 4x plus c. I did not write that 4 nicely. 1/4 times e to the 4x plus c. And if you ever had doubt, you know you can always check your answer by finding the derivative and making sure it matches with this. So most of this was basically just using stuff that you already knew. You were already comfortable with u substitution. And if there's anything I want you to remember from this, just like I said before, anytime you just have e to the x, I'm not talking about like 2 to the x or 10 to the x or whatever. You specifically just have e to the x. If you have just that, you already know. If you take the derivative of that power, it's 1, and multiply by the original, 1 times e to the x, basically gets you the same thing as you started. If you do the same thing, its second derivative will be the same thing, so on and so forth. E to the x is that special equation where it's its own derivative, thus it is also its own antiderivative. It's a very neat trick. But anyway, that's the one thing I want you to remember from this lesson, that e to the x is its own derivative and its own antiderivative. And with that, for part 2, I got a short, sweet assignment, just 5 simple questions similar to this. And with that, 5.4 is done. If you have any questions, email me, and I will see you guys later.